All right, welcome back. We are still talking about functions. So I've got this guy open again, our little primer guy, and we've got a few functions in it. First thing I'm going to talk about is function prototypes. So basically, the way that we have this file structured right now is one function right here, one function right here, and then the main below it. And we don't call any function until after it's pretty much defined. So like is prime is down here. We've already said what it is up there, and then we've got the call primes to xy right here, but we've defined it up here, so it's all right, we can use it. Pretty much you can't use a function if you haven't written it yet, or if you haven't defined it yet, or declared it, that's the right word. But you don't really want to stack your main function or your main file, your main.c, with a bunch of functions before your main. Normally you would just have a couple includes. You include the header files up here, and then you'd have your main written out. And if you had other modules that needed these functions to be written out in, you'd go ahead and write these functions in those modules and then compile with them, and then include the headers here. And basically all that would be in the headers is this right here and this right here. And so this right here is actually kind of fine as long as somewhere you have written out what these functions actually do. So now you can actually write them down here. Just do like, take this line, exactly how it is here, and then rewrite it down here with the function body behind it. And so when this right here, when the compiler gets to here and it goes, oh shit, I gotta look for this function, I gotta make sure that I have one that can take an a and a b, which are two integers, it'll run up here and it'll go, okay, yep, no, yeah, we got one, it's right here. And then when the compiler goes to link everything together, it'll grab everything and it'll find your function. If it's not defined there, then that's when it'll screw up. You get linker errors. But as long as you have it defined or written out as a prototype up here, or in a header file that you include up here, then you'll be fine. You'll be able to write your functions somewhere else, and then your main can be clutter-free and all that good juju. Another thing I kind of wanted to touch on a little bit is, say you have a void function that just like prints a message, and then it takes in like a char pointer m, which is your message, and then it prints it out. So say you have this guy right here. When you call him down here, it's just going to look like print message, and boom, you call it with the parentheses like that, sort of like you call this guy with the arguments in parentheses. Oh wait, whoops, I'm stupid. You need to send in something, so you'd have a message here. So you put your arguments in here, and then because it's void, you're not assigning it to anything, it just sits on its own line, it's its own statement. It's as if the body of the function were placed down here. As if. It's not really the same because of stacks and all that dumb shite. But say you have something that returns an int but takes nothing. The way you would call that is just with parentheses like that. So there's no arguments, but you still need the parentheses. If you left these out, then it would just say, hey, that's the name of something, but you're not telling me to execute something right here. That's not a real statement. Whereas that goes ahead and it calls the thing. If you leave it on its own line like this, though, it'd be kind of like the same as just putting like a on a line, if a was one of your variables, nothing will happen. It'll like throw that in a register and then throw it right away. So if you want to actually keep this, your integer that's getting returned, you'd have to say like a equals print message, or you use it somewhere that it gets thrown into like a format of a function or whatever. Another thing to realize is that a and b right here, they get sent into this x and y, and then down in that function body, the x and the y get used. And if these weren't constant, like if they were just integers right here, you could change x and y in the function, but it's not going to change your a and your b. Now if you send in a pointer, an address, or something, then yeah, you can change the variable at that address, and you can also do this dumb crap, pass by reference. So this function, instead of getting x and y as integers, it'll get the addresses of those variables, and you can kind of treat it the same as a pointer or whatever. You just use the address of it, and so you can change a and b if you pass by reference. But that's something you should Google and read 1,000 paragraphs and all that about, because it's kind of in-depth and crazy. The last thing I'm going to touch on is recursive functions. So say you have what, like Fibonacci, right? And you get like an int n. You want like the 10th Fibonacci number or something. So everyone should know Fibonacci is basically something like if your n is less than 2, you just return n, right? So if you're looking for the first number, it'd be a 1. If you're looking for the 0 number, it'd be a 0, something like that. And then else, so otherwise, what is your number? It would be fib of n minus 1, right, plus fib of n minus 2. But this right here, this is the function that we're writing. So how can I call the function from within the function, right? The thing is, you can. It's a recursive call. So basically every time it hits this else block, it'll call the function twice with 2 different values, and when it hits these base cases, it'll return n back up, and it'll fill in. So if it asks for like fib of 2, it'll look for 1 and 0, and then those will each return 1 and 0, and you'll get fib of 2 is 1. So you get 0, 1, 1, 2, 3, 5, all that crap. But Fibonacci is actually a terrible example for recursives, because this is calling the function twice on the tail call, and so if you say like fib of 100, you'll get like 100 factorial calls or something, and you'll blow up your computer and everyone will die. But recursive functions actually come in pretty handy, and a lot of times they're not factorial growth. Let's see, what else is there with functions? I don't know. Sounds like that's it.